Okay, practice 1 through 4 is the first set of problems we want to do on this assignment. So for each scenario in its graph, identify the appropriate function family, then based on the problem situation, identify whether the data values in the graph are discrete or continuous. Then identify the graphical behavior of the function. Okay, so on number 1 here, first off, I notice it's U-shaped. Anytime I see U-shaped, which comes to mind is it's a quadratic function. Second thing is, tell me what a quadratic function is doing here. Increasing, decreasing, maxes and mins, anything like that. So first thing I notice is my eyes are going down. It turns down here at the minimum, and then it continues to increase. So it's decreasing and increasing, and it also has a minimum. Then the other thing they want us to talk about is right here, which I think is going to be the tricky one. It's talking about when it's continuous or discrete. So a lot of times it's just easier to draw a continuous graph, especially using your graphing calculator. It's going to be easiest just to go ahead and graph it, and you get a continuous graph. But that's not always the case, where in this case we have a scenario, we have a word problem that goes with it. And sometimes in word problems, that graph needs to change to discrete. So in this instance, when we read about it, I'm looking at the domain, and the domain here is the number of tennis balls. So think about it. Tennis balls are essentially whole numbers, okay? You can't have a half of a tennis ball. You can't have a negative of a tennis ball either. So in this problem, our domain is going to be essentially 0 and above, but only the whole numbers. So we're talking positives, but we're not talking decimals or fractions. We're not talking about 1 1/3 of a tennis ball. We're talking whole tennis balls. So the domain then, it's going to be a discrete graph first off. And the reason why it's discrete is because the domain is going to be everything from 0 to infinity, or another way to say this is all whole numbers. Now when I say the word all whole numbers are 0, 1, 2, 3, 4, 5, does not include fractions or decimals, and does include negatives, okay? Number 2, practice 1 through 4, so number 2. First thing that jumps out is V. It's a V-shaped graph, so that is the absolute value function. Second thing is, in any absolute value, we have, that's not decreasing, that is increasing. We turn up here at the max, and then we start to decrease. So we are increasing and decreasing, and we have a maximum. Okay, now on this one, we're trying to figure out continuous or discrete. And the first thing I notice is down here, time, that is in minutes. And time can be represented as fractions and decimals. So here it is going to be a continuous graph because we can talk about tenths of a minute, a fraction of a minute. So that's why we are going to say it's continuous. And that means then the domain here, because we are talking time, we're starting right here on the x-axis at 0 and going to the right. So we're not going to negative. We're not going to have negative time. So we're going to go from 0 to positive infinity. And because we can say fractions, we're going to say all, and let's switch that. We're only doing the positives, all positive real numbers. Number 3, first thing I notice is that curve is a exponential curve, okay? It is only increasing. And then, yeah, I think that's everything. Okay, then we have to figure out if it's continuous or discrete. So in this case, I'm talking about a local television company determines that the revenue it gets from running ads doubles each year. So in that problem, the function graphs the revenue from advertising over X years. So same thing here with time. I think you could actually argue this one either way. I would have actually thought this one would be considered discrete myself, because it says it doubles each year. Now, I'm looking at the key, and the key says continuous. But if it's doubling every year, I don't know. I'm thinking it would have been called discrete because it doubles every year. Now, we can talk about in revenues, when you report revenues, you do talk about that in terms of quarters. So that maybe is why they're talking continuous. So like there's quarterly reports, just like your quarterly progress reports that you get, quarter 1, quarter 2, quarter 3, quarter 4. That's maybe where they're going with the revenue there for that. So more talk about that. That's where I'm thinking that's where they're going with this. It's continuous, and that implies then the domain is going to be from 0 to infinity, or all positive real numbers. Now, the reason why I'm saying 0 to infinity is we're starting off at year 0 and then going to the right. Number 4. First thing I notice is it is a line. It's a straight line. That's a linear function. Without even reading it, look at the graph. It's a linear function, and it is decreasing throughout. Now, if it's continuous or discrete, we need to read the scenario. We're handing out glow sticks to children who attend. They start with 200 glow sticks, and each child receives 3 glow sticks. And as you keep handing out glow sticks, you start to decrease in the number of glow sticks that you have. So the more children that you have, the less glow sticks you're then going to have, which makes sense. You're starting off at 200, and then it starts to decrease. And what I notice is the domain is the number of children. Well, you cannot have half of a child. You cannot have a third of a child. You can't have 0.9 of a child. So therefore, this is going to be technically considered a discrete graph like that going down. So the domain then is going to be same deal. 0 to infinity. We're starting off at 0 children. We have 200 glow sticks. But as we start to hand them out, they start to go down. Eventually, we get to a certain amount of kids where it's gone. So it's going to eventually stop. But 0 to there. And I'm going to say another way to write that is all whole numbers, because we're talking about children. Children are not fractions. Okay, then I asked you to do the other one, which is review number 1. Choose the graph that represents the function. And what I'm doing here is, I'm not even using my graphing calculator. We've talked about this enough now. What I want you to be able to do is look at the equation that's there for the function and then piece out what it should be for a, b, and c. So whenever I see that x, most importantly squared there, x squared, that should always be associated with something that is u. That's what it looks like a v. That is u-shaped. So the only one that's u-shaped is not A, not B, it is definitely letter C. B is absolute value because it is V-shaped. And A is just a line. This is what it is, a linear function. And C is then quadratic, which is what we've got there for the x squared. And if you wanted to confirm it, I'm going to switch over my screen here and make sure I do this. We can do it on our graphing calculator to confirm. So bring up the graphing calculator, we go y equals, clear it out, and then we're going to graph that function. Negative, we use the negative button here, x squared, we've done this a lot, plus 3x, hit graph, and there we go. That was a confirmation of things, but we did not need to do that because the x squared tells me it should be u-shaped. Okay.